Okay, we have a sine line given to us, or half of a sine line given to us. And we know that this function f of x is continuous on the closed interval -2 to 5. Now, the fact that that's a closed interval is important during this problem versus an open interval. Okay, and the sine line is given to us below. Well, don't forget what the derivative is. It's the slope of the function. So if the derivative is negative, then the function itself is going to be decreasing. And if the slope is positive, then the function is going to be increasing. Again, decreasing when it's negative. When the derivative is positive, the function is increasing. When the derivative is negative, the function is decreasing. So we need to include that kind of information when you are taking an assessment. If you want, you can put arrows in additionally, but for me, I want to see the words because that's going to be important for your AP exam as well. So sometimes it's helpful for students to see the visual part of it too. So I'll put in the arrows. Okay, now it says at what 3 values of x could f assume its greatest value on -2 to 5? Well, in this region, my function is it's increasing, and then it's decreasing, okay? So at x equals 1 would be one possibility. Likewise, between 2 and 3, it's increasing, and then it's decreasing after 3. So x equals 3 is another possibility. Now the piece of the puzzle here is that it says, and it's written in italics, so it means that there are 3 possible values of x. Well, I'm going to make a quick possible graph of this function. Going from -2, function's decreasing to 0, then it's increasing to 1, and then it's decreasing to 2, and then it's increasing to 3, and then it's decreasing again, okay? So that's one possibility, and ultimately the way I drew that, the value at x equals 3, that's the highest one we have. But what's often not accounted for by students is this value at -2 could have gone way up, okay? I don't know where it's starting. I just put in an estimate. So when you have a closed interval, you need to consider the endpoints. Since this function is decreasing from -2 down to 0, okay, we could have had one of the greatest values at -2. So likewise on part B of the question, when could the function assume its least value? Well, it could have happened at 0. It might happen at 2. Or, likewise, it could happen at 5. So what you need to be careful of is if you're on a closed interval, be sure to consider the endpoints as possible max or mins.